So now this is the comparison between Bpsk versus Qpsk, and also we will recall some of the important related formulas. In case of Bpsk, say suppose data rate is constant, and then in another way we will consider bandwidth is constant. In Bpsk, suppose if data rate is constant, to transmit RB data over a channel, we need bandwidth, BW bandwidth. Suppose if it is QPSK system, to transmit same data rate over a channel, we need only half of the bandwidth. Why? Because in case of QPSK, we are having 4 symbols. Each symbol will carry 2 bits. So that's why there is the reduction in the bandwidth. Or otherwise, same thing we can consider in the different manner, like considering bandwidth as constant. So in case of Bpsk, I am having some bandwidth. Using that bandwidth, I can send RB amount of data. In case of QPSK, anyway, I cannot change the bandwidth because bandwidth is fixed. So, but once if you go for QPSK scheme, the bandwidth, using the same bandwidth, instead of sending RB, now I can send 2 times of RB. 2 times of RB. In case of Bpsk, I am having 2 symbols. Okay, symbols we usually denote like capital M. In case of QPSK, I am having 4 symbols. So when I am increasing M means increasing the order of modulation. If suppose I am increasing M value means I am increasing order of modulation or higher order modulation, increasing order of modulation. So once if I go for higher order modulation, either I'm getting advantage in terms of bandwidth if data rate is fixed, or otherwise I'm getting advantage in terms of data rate if bandwidth is fixed. Okay, any one way. Then what is the other problem we have observed, or maybe in future we will observe? Now it may not be evident now because for Bpsk and Qpsk the probability of error may be same. That d minimum distance between the symbols may be same. So maybe here we may be having same probability of error. But what happens once if you go for 8 PSK system? If you go for 8 PSK system where m is equal to 8, okay, I will be having 8 number of symbols, then what will be the bandwidth requirement? Now it gets reduced by 3. Okay, instead of BW by 2, it gets reduced by 3. Or otherwise, once if the bandwidth is fixed, in case of 8 PSK, using the same bandwidth, I can transmit 3 times of data rate. 3 times of data rate. Okay, so for Bpsk and Qpsk, the probability of error may be same. Probability BER, same BER. Okay, for Bpsk and Qpsk, but that BER of 8 PSK or BER or probability of error of 8 PSK is definitely greater than the probability of error of QPSK. So what I'm telling now, once if you go from QPSK to 8 PSK, what is the problem we will be facing? The probability of error of 8 PSK is greater than the probability of error in QPSK. So that means once if I go for higher order modulation, I may be getting advantage in terms of bandwidth or bit rate, but what is the other problem I am facing? The probability of error is getting increased, but at any point of time, probability of error has to be within some level, or otherwise we cannot send useful information over a channel. Whatever the information that we are sending, that may be in error at the receiver side. That is the another problem. So why it is happening? See, because once if you go for 8 BSK, the d minimum, so what is the another idea? The d minimum, the distance between the symbol in case of 8 PSK will be less than the distance between the symbol in case of QPSK. So once if the distance between the symbols decreases, definitely the probability of error will increase. The probability of error will increase. Again, what is the, now I go for 8 PSK. I go for 8 PSK. Say here we will be having 8 different phase. In case of 8 PSK, I will be having 8 different phase. So just to draw a imaginary circle, in that we have to put 8 symbols at different phases. At different phases. So this is the 8 PSK. Now you can easily observe between the symbol, definitely the distance is minimum. Again, once if you increase the radius of the circle, the distance may become higher between the symbols. The distance between the symbols may become higher once if you increase the radius of the circle. So what is the main assumption here? Once if you go from QPSK to 8 PSK, the main assumption here is power is constant. So the analysis is, we assume that power is constant. Assume power is constant. Power is constant. The average power of the symbol is constant. So once the average power of the symbol is constant, then definitely the D minimum in case of 8 PSK, definitely D minimum in case of 8 PSK will be less than D minimum in case of QPSK. So what is the main assumption here? The power in QPSK system and then 8 PSK system is same. Now, okay, under that assumption, we are doing the analysis. So what is the main observation? So once if I increase the order of modulation, that means in case of QPSK, the order is 4. Once if you come to 8 PSK, the order M is equal to 8. Once if you increase the order of the modulation, either I am getting advantage in terms of bit rate, or otherwise I am getting advantage in terms of bandwidth. Okay, either user bandwidth can be reduced, or amount of data that can be sent in a given bandwidth can be increased. So I am getting this advantage. But what is the other problem? Once if you go for higher order modulation, the problem is the probability of error, BE or bit error rate, is increasing. It increasing again. All these analyses are under the assumption of power is constant. Under the assumption of power is constant. So the moment we go for higher order modulation, I'm having some advantage in terms of bandwidth and bit rate. The problem is with respect to the probability of error and BER. Now, how to reduce the probability of error or bit rate? How to reduce the probability of error or bit rate? That is the challenge here. How to reduce BER, bit error rate, or probability of error once if you go for higher order modulation? The only way is by increasing the radius of the circle. Only way is increase the radius of the circle. Increase the radius of the circle. So that's, again, easily you can imagine. Once if I increase the radius of the circle, instead of putting smaller circle, if I put bigger circle, still I can have 8 symbol, but the distance between the symbol may get increased. Okay, by putting the circle with a larger radius, I am trying to increase D minimum, so that what will happen? The probability of error will decrease. But what is the problem? Once if you put a larger circle of radius, the problem is the power will increase. The power will increase. That is the major problem. The power will increase. So you may try to reduce the probability of error, but what is the problem? Automatically the system power will increase, so cost of the system will increase. That is the major limitation in the digital communication system. So that so what is the conclusion here? You can transmit the data at any rate for a given bandwidth by going with the help of the higher order modulation, but the problem is with the transmitted power. So we need to increase the transmitted power in order to keep the probability of error within a certain level. That is the major limitation in the communication system. So once if you want faster communication system, a faster communication system with the optimum error, with the less error, you need to spend more power or more cost. Okay, that is the conclusion. Okay, then we will put some common formulas between the symbols and bit rate. So symbol rate, RS symbol rate is in general RB, bit rate divided by log base 2m. Okay, that is the common relationship between the symbol rate and bit rate for any communication system. M can be anything. It can be 2, 4, 8, like anything. So where RS is the symbol rate, RB is the bit rate, where M is the order of the modulation, order of modulation. So in the same manner, you can also define bit rate. Say TB is equal to TB is equal to TS divided by log base 2m. Again, bit duration. A bit duration is equal to TS divided by log 2m. Okay, log 2m. Where what is log 2m indicating? Log 2m at any point of time is indicating how many bits are there in one symbol. So number of bit, this is number of bit in one symbol, number of bit in one symbol. This is the indication of number of bit in one symbol, Okay. The next we'll go for QAM, quadrature amplitude modulation. Or before that, we'll discuss the variant of PSK, that is DPSK, differential phase shift keying.